Welcome back to London Gold, everyone. Thank you so much for the support. In today's lesson, we're going to go through how to balance chemical equations. So I'm going to walk you through a simple step-by-step guide that you can follow to get the correct answer every single time. We're going to begin with some easier examples and then finish with some harder ones at the end. So let's have a look. Let's start with the aim of balancing an equation, which is to make sure you have the same number of each type of atom on the left-hand side of the equation as on the right-hand side of the equation. So it looks like this, where A and B is a compound on the right, and then A and B are the reactants on the left. So the way to get to this is through a simple set of rules. The first rule is this: you can't change these numbers. But rule number 2, you can put numbers here, although you don't always have to. Rule number 3, when a number appears before a compound, an element, something like this, it means you multiply everything in front of that number by 4. So you have 4 calcium, 4 carbon, and 12 oxygens, because 4 times 3 makes 12 oxygens. So now let's look at a few examples. We're going to go through what I consider an easy example, an intermediate level example, and then one that is harder. Example number 1. Remember, the aim is to make all of the atoms on the left the same as all of the atoms on the right. So you have the same number of sodiums on the left as on the right, and the same number of oxygens. So a quick way to do that is to do a count of how many there are before you balance the equation. So you can see there are 1 sodium on the left, 2 on the right, 2 oxygens on the left, and 1 oxygen on the right. So it is not balanced. So think about what I said earlier. If you put a number before an atom or a compound or whatever is in the equation, the whole thing is multiplied by that number. So the first thing I'm going to start with is the oxygens. There are 2 on the left, and there is 1 on the right. So I'm going to put a 2 on the right. So now that changes the oxygen to 2 on the right. So I can tick to show that both the oxygens are the same. However, you can see that the sodiums have now been changed, and we have 2 times 2 makes 4 sodiums on the right. So now I need to put on the left-hand side a 4 to balance the sodiums, and that's finished. For example 2, we're actually going to look at 2 different equations. The first one is this, and the second one is this. So remember what I said, you can only put numbers before the species in the equation, in the reactants and products. You cannot change numbers that are already there. So a quick count gives us this. And you can see that the aluminiums are already balanced, but that may change. The ions are not balanced, and the nitrogens are not balanced either. So what do I start with? Well, I'm going to start with the nitrogens first. So on the right-hand side, I need to put a 2 because there's 2 nitrogens on the left. The next thing I'm going to do is balance the ions. So there are 3 on the left, and there is only 1 on the right, so I need to place a 3 on the right. So I can see so far my ions are balanced, my nitrogen's balanced, and then the last thing to do is to put a 2 on the left for the aluminiums, and now the aluminiums are balanced. So when you have an equation that looks like this, there's actually a quick way to balance this, and it comes from recognizing that you have a mixture of elements and compounds. Especially when you have this situation. When you have one element in the equation and the rest are compounds, the rule is this: balance the element last. Let me show you why. Quick atom count. Carbons are not balanced, hydrogens are not balanced, oxygens are not balanced. Oxygen is the element. We do that last. So, which one do I start with? The carbon or the hydrogen? It doesn't matter, because this method will always lead to the correct balancing. So I'll start with the carbons. As you can see, there are 3 carbons on the left and there is only 1 on the right. So I put a 3. There are 8 hydrogens on the left and there are only 2 on the right. So I put a 4. And now we do a count of all of the oxygens on the right hand side. So we have 3 times 2 makes 6 plus 4 times 1 makes 4. 6 plus 4 gives a total of 10 oxygens. So something times 2 makes 10, which is 5. So the reason you leave the element until the end is because you can put whatever number you like before it to make it balance. Because you don't have to worry about other elements in front of it, like you have in a compound, being multiplied by that number. So it's just oxygen. So it's really convenient. You can put a whole number, a fraction, whatever is needed to make it work. Example number 3. This is a hard one. And we need to remember to do the element last. So where do we start? Well, so let's take a look at the oxygens on the right hand side first, as well as the hydrogens. And just something to bear in mind, when you see numbers that make up chemical formulae, either in the reactant or product side, where they go into a higher factor. So for example, on the right hand side, I can say there is 3 oxygens in KiO3, and then water contains 2 hydrogens. The 3 and 2, the number that sort of comes to mind there is 6. So when you see numbers like this, 3 and 2, 5 and 4, or whatever it may be, think of a higher factor they may go into. So if I put a 2 on the left hand side, that would balance the hydrogens, but the problem we have there is you can already see there are more oxygens to begin with, and this would only make 2 oxygens. So I know immediately that that number is not going to work. So I have to think of a higher number. So the next one I'll try is 3. And now we have 6 hydrogens on the right hand side. And now I have to do the same to the left to give this. And I can see that the hydrogens are balanced. Next, I will turn my attention to the oxygens. So on the right hand side, you can see I now have a total of 3 plus 3 makes a total of 6. And the left hand side also has 6. The oxygens are now balanced. Finally, before I balance iodine last, is to look at the potassiums. So I have 2 on the right hand side and 6 on the left hand side. So to make this work, I will need to add a 5 before the Ki. Now the potassiums are balanced. Lastly, I balanced the iodines. There is a total of 6 on the right, which means on the left hand side I need to place a 3. And it's done. And let's look at one final bonus example, which is equations involving brackets. So you may have equations that look like this. And is there a quick, easy way to balance these sorts of equations? Well, there is a shortcut to the answer. So what you do is you look at the bracketed part of whatever molecule is on the left hand side or the right hand side. So in the case of example A, it would be the nitrate, which I'm underlining in green. And you can treat that as just one entity, one thing. So you can see on the right hand side, there are 2 lots of NO3. Therefore, on the left hand side, I can also see an NO3, which is there. Now, I know what you're thinking, there's no bracket there, but you can just think of it as a standalone NO3, even though it's attached to nitric acid. And you have 1 lot of NO3 on the left and 2 lots of NO3 on the right. So, to make the left the same as the right, all I need to do is add a 2 before the HNO3. And a quick atom check shows us that we have 1 calcium on the left and 1 on the right, so that's balanced. 2 hydrogens on the left and 2 on the right, so that's also balanced. And then 2 NO3s on the left and then 2 NO3 on the right. So this has been balanced just by using 1 number. Now let's look at example B. I'm going to apply the same method again. I can see on the right hand side 3 sulfates, and on the left hand side you have 1 sulfate there. So the number I will use on the left hand side will be 3. Now obviously that will change the hydrogens on the left hand side. So we can see there are 3 times 2 is 6 hydrogens on the left. So now I need to make the hydrogens on the right the same by doing this. And now the hydrogens are balanced. Finally, the aluminiums, 2 on the left. And that is now balanced. So I hope that was helpful today. Please do check out the other content I've made and all of the other sciences. And if you had any value, please subscribe. And I will see you in the next one.